Alright, so that's a really bad prediction. So now we're going to get the good prediction, which we can clearly see here. That's 6.5, and we'll get a prediction around here, which will correspond indeed to the salary that this person mentioned. So let's do this. Let's create a new code cell here, and to get that prediction, we're going to do it efficiently. I'm going to copy this and paste here. And now, once again, I would like you to press pause on this video and figure out what we have to replace here to indeed get the predicted salary resulting of our polynomial regression model. So please press pause, and then I'll tell you the solution right away. Okay, let's do this. Alright, so first, the obvious thing you had to change is, of course, the name of your regressor, because for polynomial regression, we named our regressor linreg2. And then, exactly the same thing as before. Here we can't input that single position level, coming from the matrix of single feature. But instead, well, we have to exactly input, the features of this equation where x1 is equal to 6.5. And therefore, what we need to input as features is this array composed of the following features values: 6.5 for x1, then 6.5 squared for x1 squared, then 6.5 at the power of 3 and 6.5 at the power of 4, because now we have built a polynomial regression model with degree 4. Alright, so here, the exact thing that we have to predict, and we can actually input that efficiently by, taking exactly what we input here in the predict method, that polyreg object from which we call the fit transform method, to transform this matrix of single feature x into this matrix composed of the several features at the different powers. And here, well, of course, the feature value that we will input inside this fit transform method will not be x, but not 6.5 directly, like before, but once again, a 2D array containing the value of 6.5, the cell of 6.5. And so that's exactly the same as before. We need to enter this 6.5 value inside an array. Just before we had x here, x is an array, and now we have to input 6.5 in a 2D array, just like that. And now there you go, we're ready to get our predicted salary resulting from the polynomial regression model. So let's find out right away what is that predicted salary. And wonderful, the predicted salary is $159,000, which is super close to the salary mentioned by this person, as the previous salary earned in the previous company. So now we can be 100% confident to hire this person, because not only it is a good fit for the job, but also it is a very honest person. And we figured that out with polynomial regression. So congratulations, we all solved this case study. Not only we solved this case study, but you now know how to build a polynomial regression model, and you added that in your toolkit. This is your first nonlinear regression model. Congratulations for that. Now we're going to build 3 other ones, starting with the SVR, support vector for regression, and that's what we'll do in the next section. Now, for those of you who also want to study R, well, you'll find that same implementation, but in R, of course, in the next section. And for those of you who only want to learn Python, well, join me in the section after that to first learn about SVR with Kirill, and then implement the SVR model with me, which will be, by the way, on the same dataset with the same case study, so that we can actually compare the different results of our nonlinear regression models. So I can't wait to see you in these next sections, and until then, enjoy machine learning.